Assalamualaikum and hi everyone. So today we are going to learn how to use integrated rate equation in calculation. Okay, so there are three examples here. Example 1, example 2 and example 3. Okay, so let us start with example 1. Okay, so for example 1, the decomposition of compound X into its product is a zero orderation. Okay, so now this question already give us clue this is the zero orderation. That means we will use integrated rate equation yang zero order lah dekat sini. Okay, and the rate constant adalah 0.082 mole per dm cube per minute. So you can highlight this rate constant is this value here. Okay, and the initial concentration of X is 3.51 molar per dm cube. Okay, so I think it is better if you write down the information given. Okay, so K equal to 0.082 mole per dm cube per minute. For initial concentration of X is X not equal to 3.51 mole per dm cube. Okay, and then the question A asks us to determine the concentration of X after 8 minutes. Okay, so that's mean XT lah berapa. Okay, so for this one, okay, kalau kamu kata kenapa kita kena guna integrated rate equation, why don't we use rate law? Okay, so let's say lah we want to use rate law. This is zero order, so rate equal to K X to the power of 0. So last kali rate equal to K, so kita tak dapat tahu any information pasal T, tak ada. Okay, so kita nak cari concentration initial and concentration left after the reaction pun tak boleh by using this rate law. So that's why we need to use integrated rate equation. Okay, so the integrated rate equation that we are going to use is zero order punya. So concentration X naught minus concentration XT equal to KT. Okay, so if you look at this equation, datang X yang Miss ajar A. Okay, saya ajar A sebab in my example A adalah reactant, but in this question the reactant is X, so that's why I need to substitute A with X lah. Okay, so if you substitute your equation like this, then only you will get mark for formula. Okay, tapi kalau kamu tak substitute macam ni, contohlah kamu tak buat X but you write down as A. Okay, boleh juga, but you need to add 2 more words lah. Okay, so you have to let A equal to X. Okay, so salah satu daripada tadi. Okay, saya tengok keadaan lah. If the reactant is simple macam X, usually I will just substitute dalam ni X. Okay, so X naught minus XT equal to KT, and then the initial concentration is 3.51 mole per dm cube. XT is the one that we want to find, and then for K, just substitute the value of K 0.082 mole per dm cube per minute. Okay, so saya tulis unit sebab senang saya nak ajar kamu. Okay, so T dekat sini adalah 8 minit. Okay, so 8 minutes, so you don't have to convert minutes to second, because as you can see here, the unit of rate constant adalah mole per dm cube per minute. So the unit is in minute, so your time can also be in minute. Okay, kalau kamu tukar minute to second, you have to convert this also to second. Okay, so susah, so kenapa nak menyusahkan diri? Okay, so better tak payahlah. Alright, so now solve kan this one, your concentration X after 8 minutes. Okay, saya dapat 2.854 molar. Okay, ataupun if you want to leave your answer as 2.85 molar also can. Alright, so that is for A. Okay, so itu untuk A, and then B. Okay, so for B, let us read the question. Dia kata how long will it take for the concentration of X to drop to 1 molar. Okay, so the question asking for how long. Okay, so you should be able to interpret this. Kalau soalan minta how long maksudnya time lah. Okay, so the question asking berapa lama masa yang diambil untuk concentration X to drop kepada 1 molar. Okay, so now the XT is 1 molar lah. So this value here is actually concentration X after time T. Okay, so we are going to use the same formula. So X0 minus XT equal to KT. X0 kita masih sama, 3.51 mole per dm cube minus 1 mole per dm cube. Okay, K kita sama. Kenapa K masih sama? Because this is still the same reaction yang sama. Okay, so kita boleh guna nilai K yang sama, 0.082 mole per dm cube per minute. Okay, and T yang kita nak carilah. So your T should equal to 30.61 minute. Okay, so time taken kamu pun dalam minit because your K dalam minit. Okay, so that's why dalam minit. Okay, so that is our answer for A and B. Okay, so for example 2, calculate the half-life of radium if 5% of sample of radium took 2.5 years to decay. Okay, so if you read this question, you will feel like mana clue order of reaction dia tak beritahu kan. Okay, tapi for your information, if you see something yang ada the word decay, so maksudnya itu adalah first order reaction. Okay, apart from decay, the word radioactive pun boleh juga. Okay, so kalau kamu jumpa perkataan radioactive, decay, that means dia adalah first order reaction. Okay, so now we know this reaction adalah first order. So bila first order, baru kita boleh determine which formula half-life yang kita nak gunakan. Okay, so half-life for first order is T half equal to ln 2 over K. Alright, so ln 2 tak ada masalah, but our problem now, we don't have K. K is not given in the question. Okay, so that means we have to determine the value of K first. So we need to use integrated rate equation to determine the value of K, then substitute into this formula. Okay, so the integrated rate equation that we are going to use is first order punya lah. So ln, in this case ln radium, okay, not minus ln concentration radium T equal to KT. Okay, so tapi masalah dia tak ada apa concentration dia bagi. Okay, so dia bagi percentage dekat sini. Okay, another point that you need to take note adalah kalau first order, you can use percentage. Okay, kamu boleh guna percentage dalam pengiraan first order. Okay, so contohlah kalau ln initial, percentage initial berapa? Usually percentage initial 100% lah. So ln 100 minus with, okay, ln, okay, so over here ini trick dia. Okay, I always emphasize that 80 is the concentration left ataupun the concentration remain after time T. Okay, so kalau ikut ayat ni dia kata 5% of sample of radium took 2.5 years to decay. That means after 2.5 years, 5% of radium decay. That means how many percent left? So the answer is 95%. Okay, so that's mean over here you need to substitute ln 95, not ln 5%. Okay, for those yang substitute ln 5%, that's mean dia tak faham 80 tu adalah concentration yang tinggal after reaction. Okay, so the value of K kita nak cari T. Okay, so our time here is given dalam year. Okay, so tak perlu, you don't have to convert to second, tak perlu. Kalau kamu nak convert second, jenuh lah kan. Okay, so kita biarkan dia dalam unit year. Okay, so over here is 2.5 years. Okay, so tekan your calculator, your value of K should equal to 0.02052. Okay, so now we need to think what is the unit of K, what is the unit of rate constant for first order. Kita hafal first order unit dia per second, but this one is not in second, so dia jadi per year lah. Okay, so per year. Alright, so kita dah ada K, then kita back to our main focus adalah nak cari half-life by using this formula. So substitute lah. So T half equal to ln 2, K kita adalah 0.02052. So tekan calculator, T half sepatutnya equal to 33.782 years. Okay, so kiranya time taken for the for radium to decrease to half of its initial concentration adalah 33.78 tahun. So maksudnya after 33.78 years, 50% of radium dah decay. Okay, tinggal another 50%. Alright, so that is for example 2. Next, kita proceed terus pergi example 3. Okay, so for example 3, the decomposition of an organic compound Z is a second order reaction. Okay, again this question quite easy sebab dia dah bagi tahu this is second order reaction with rate constant K 2.2 exponent -2 mole per liter per minute. Okay, so if the concentration of Z after 3 hours adalah ini. Okay, so concentration of Z after 3 hours adalah nilai itu. Okay, so let us write down lah. Okay, so K equal to 2.2 exponent -2. Okay, and then our time is 3 hours. Concentration Z after 3 hours, that means ZT lah, is 0.125 mole per liter. Okay, so kita nak cari initial concentration Z0. Okay, so this is second order, so we need to use this formula. 1 over ZT minus 1 over Z0 equal to KT. Okay, so 1 over ZT as given in the question is 0.125 minus with 1 over Z0 is the one that we want to find, and K kita is 2.2 exponent -2 mole per liter per minute, and then for our time is 3 hours. Okay, so ini dia clash unit dia. Kalau kamu tengok, time is in hour while your K dalam per minute, so you have to follow K. So this 3 hours, so 3 times 60, tukarkan dia kepada minit. Okay, so concentration Z0 equal to, okay, so saya dapat 0.2475 molar, ataupun if you want to give in 2 decimal places, the answer should be 0.25 molar. Okay, and then for definition of half-life, okay, definition half-life boleh rujuk nota lah. The half-life is defined as time taken for the concentration of Z to decrease to half of its initial concentration. Okay, so and then saya proceed terus kepada C, what is the half-life of the reaction. Okay, so since this is second order, so our formula for half-life is T half equal to 1 over K times with concentration A0. Okay, so again over here I will substitute A with Z lah, sebab our reactant here adalah Z. So T half kita substitute je nilai, so T half equal to 1 over K adalah 2.2 exponent -2. Z kita yang baru kita calculate tadi adalah 0.2475. Okay, so T half equal to 183.64 minute. Okay, so half life untuk second order reaction ni adalah 183.64 minutes. Okay, you have to use 4 decimal places for value of Z0. If not, you are not going to get this answer. Okay, I think that's all for this video. Thank you. Bye.